de la División de Tecnología aplicada en el campo de la construcción en la división de Trimble Buildings. Con más de 19 años de experiencia en la industria promocionando la tecnología entre equipos de diseño y construcción, David brinda una amplia comprensión de los procesos de modelado e información de la construcción, así como el diseño de la construcción virtual.
All right, well, good afternoon, everybody. Thank you for having me here for the conference. I'm very excited to be here. Just to give a brief introduction into myself and into Trimble before I go into the presentation. Again, my name is David Burczyk. I am a segment manager for our field technology group within Trimble Buildings. And my team is responsible for the development of robotic total stations, 3D laser scanners, and mixed reality solutions that are being used in the AEC industry by architects, engineers, contractors, and mechanical, electrical, and plumbing professionals as well. But within Trimble Buildings, we provide solutions across the entire building continuum, starting with design, using the SketchUp application, going into fabrication, and construction, which is where my team resides, and then moving into the facilities management. So we provide solutions across the entire building's life cycle from start to finish. So my group hangs out here in the construction area where we provide the hardware solutions that takes all this 3D model information that's being spent from a planning standpoint and makes sure that that information and that coordination gets taken out to the job site so it is accurately laid out and accurately installed. So what I want to talk about today is just some of the solutions that our group is developing and how these technologies are starting to influence the way construction is being done. Our main solutions that we provide focus around field layout using robotic total stations, in which we use a tablet controller to take that 3D model that's being designed in the office and being coordinated and take it out to the field. And you take the information from that 3D model and you accurately lay it out on the job site. Then you also have 3D capture solutions where you go out with a 3D laser scanner and you capture those real-world conditions. You turn that into a 3D model deliverable, and you can document the progression of construction. So you're scanning before construction begins, you scan during construction, and you can even scan at the end of construction once you go into the facilities management side of things. And then you also have mixed reality, where you take all this information, all this data that you're gathering and you're working with, and you start to visualize it. And you can visualize it both in the office with the design team and also out on the job site. And the last two solutions there, the 3D capture and the mixed reality, is really what I want to focus on today and how these technologies are starting to emerge and really influence the construction process. So let's take a look at 3D capture. So 3D scanning is really starting to become prevalent within the construction process, and that's mainly because there's this industry demand to document the as-is conditions, and owners are wanting more and more accurate information into their models. And with 3D laser scanning, you have the ability to go out and actually do that. Capture the real-world conditions in a small amount of time, and then add that into your 3D model. And as you document these as-is conditions, you can then use this as part of the pre-construction planning process, determining how you're going to do the site logistics, how you're going to do the installation of prefabricated assemblies. You can track the progression of construction, be able to use the scan data to tie back into the 3D or the scheduling model, and be able to determine if things are on track with construction based off of what the actual conditions are doing. And you can also use it as a project deliverable at the end of projects. A lot of owners are now requiring the contractors to turn over 3D laser scans of where they installed systems in the building before they get covered up, just so that they have that information. So as you go into facilities management, you have the ability to go in and see where things are behind the wall before you start to actually tear apart the building. And one of the new areas that scan data is being used around is with construction verification, taking the 3D model, comparing it back to scans that are taken on a regular basis. So just taking a look at some of the construction workflows around 3D laser scanning, the one that's most common that you'll see 3D laser scanning right now is around as-built deliverables. Taking scans, going out, capturing the real-world conditions, and turning that into a model deliverable. And what you're seeing up on the screen right now is an example of an electrical contractor that I worked with, in which they were doing a wastewater treatment plant, and at the end of the project, the owner was requiring them to go out, scan everything that they installed, and turn that into a model deliverable. And what they did is they went out, they scanned the facility, and that's what you see on the left-hand side of the screen there, and then they modeled off of that data. And on the right-hand side, you can see the model deliverable that they created. And so more and more projects are starting to require this type of information being handed over, and that's why 3D laser scanning is starting to become more and more part of that overall construction process. But then some of the other construction workflows that are being done are focused around concrete construction. This is a general contractor back in Colorado, which is where I'm from, where they've now incorporated scanning as part of their construction process with concrete. Before they go out and actually pour the concrete on the deck, they actually take their laser scanners out onto the job, and they scan the deck within just about 30 minutes or so before concrete gets poured. And they use that information to document the location of where all the reinforcement is in the slab. And they're particularly concerned about situations where they have like post-tension cables, because they don't want to cut through those cables if there's changes that have to be done to the slab later on in construction. So they've made it as part of their workflow where they go out onto the job site before concrete gets poured, and they scan that whole slab or that whole deck before the concrete gets poured. They registered the scan data, and then they take it into their 3D model. So now that becomes another reference drawing in the background in which now they have information showing the pre-pour conditions overlaid on top of the 3D model. And then they come in at the end of the pour and do a post-pour scan, bring that into the 3D model. And then as a result, they now have very accurate information showing the actual conditions of the slab, both pre and post-pour with the concrete. So then if any changes come in during the design process, for instance, the moving of sleeves that might have to be changed from where they were actually installed during the concrete pour, they can actually come through, take a look at the scan data, determine where the safest location is to move those sleeves and not interrupt any of the post-tension cabling, and then take the coordinates from those new locations, load it into a robotic total station, and then do the layout of those points using the total station. And then one of the new areas where the scan data is being used is around verification, taking the scans, comparing it back to the 3D coordination model. And in this particular application, what's happening is you're taking that overall 3D coordination model and bringing in scans that get captured on a regular basis, whether that's daily, weekly, or monthly. And you bring that scan data into your coordination model, and you run an analysis. And what the software does is it goes through and it color codes all the modeled elements after it runs that analysis, where anything in green shows that it's been installed properly, it's within the tolerances that you've specified. Anything red indicates that the items are missing, they haven't been installed yet. Anything purple indicates that it's occluded, meaning there's not enough scan data there to run a proper analysis, and so you have to capture additional scans. And anything that comes up as yellow means that it's out of tolerance and requires the virtual design and construction team to go back, review that information, and determine if this is actually an error within the project. But then within these types of verification programs, then what you start to see is this type of a split screen view in which the program will go through and it shows you in that split screen what's in purple. That's what was designed. So that's how it was supposed to have been installed out in the field. That's what things were coordinated to. And then next to it is where the actual conditions are out in the field. So everything in white is the laser scan data that's been shown in a white color so it's easy to read. And then a model is created by the software as well, showing, okay, here's the actual steel member and where it was placed. And so by looking at that information, you now have documentation that shows you exactly where things got installed versus where it was coordinated to back in the office. And so the teams can then take this information, create reports to be able to see what that deviation is, determine if it's actually a problem, and if it's not, then they can move on and they can actually update the published coordination model that they have with the as-built condition as they start to take a look at it. So that's kind of a new way that scan data is now starting to be used within the overall construction process. But then as you take a look at all this information, then you want to be able to visualize it, and that's where mixed reality comes into play. And mixed reality is an area that's just now starting to get a lot of press within the industry and a lot of attention. But if you look at where tech waves have been going within the industry, it started out with the PCs back in the 80s. Everyone's given this personal computer, being able to use that as a very powerful tool to start to change the overall design process. And then from the PC development sprang the development of the internet, where you had communication with other people in any part of the world. And then as you had that development of the internet, that sprung forward the development of mobile devices, taking all this powerful information that you had with the PC and the internet, putting it into a mobile device that could fit inside your pocket. And now with the development of the mobile applications, that's now led to the mobile or the development of the mixed reality applications. And this is where you're starting to see a lot of development money being poured into the overall process. And so there's lots of players in this field focused on this from a technology standpoint. But for Trimble, this is an area that's new to us. We've actually been playing around this area for over 20 years. On the left-hand side of the screen there, you can actually see our first foray into creating an augmented reality type of device. So for Trimble, we're well known for our use of positioning technology within the construction industry. And so back in 1997, we were playing around with this idea of taking the models, getting them accurately located on the job site using GPS or GNSS technology, satellites, to position the model on the field. And that's what you can see on the left-hand side there was our first kind of foray into that idea. Fast forward 20 years to 2016, and that's when we were able to release our first mixed reality application to the marketplace with a partnership with Microsoft, and that was our SketchUp viewer for HoloLens. So this is an area that we've kind of been toying around with for over 20 years. But what I always like to do is I like to show this slide as a way of kind of describing the different terms within that you'll hear when people are talking about mixed reality. You have MR, AR, and VR. And what each of those represents are different types of applications around viewing digital data out in the physical context. VR is virtual reality, where you replace your entire environment with a digital content. You're putting on a pair of goggles, you go inside the model, and you start to interact with it in that digital environment. It's literally creating a digital prototype and interacting with the building in that digital environment. AR is augmented reality. This is where you're taking a mobile device and using that as your digital window, and anywhere you go out in the physical environment, you lift up that digital window, and you can see the digital content overlaid on the physical environment. If you think about like the Pokemon Go game, that's augmented reality. And then mixed reality is kind of a combination of the two, where you take both digital and physical content, and you immerse yourself inside of it wearing a visor of some sort. And in this particular case, the image is showing you the Microsoft HoloLens application. But mixed reality is the application that really has a great influence on its use within the construction industry. And so within Trimble, what we decided to do around all these mixed reality applications is, traditionally we developed the hardware applications around this. But since there's so many players in the marketplace, and we've been looking at it for such a long period of time, a lot of those industry players like Apple, Microsoft, Facebook, have come to us saying, hey, we've got the hardware, but we don't have an application that goes with it. So we've decided to focus our energies around creating the software applications that go on any of these types of devices. So we're staying hardware agnostic and then providing the software solution that actually goes onto those. And so our focus is around the entire construction life cycle, starting with design, with the SketchUp viewer for HoloLens, going into construction with Trimble Connect for HoloLens, and then the next phase where we're starting to do research around is then taking all this digital content and pushing into the operations phase with Trimble Operations. So just looking into each of these applications a little bit deeper, we have the design application, which was our first mixed reality application that came to the marketplace, and that was the SketchUp viewer for HoloLens application. SketchUp is an application that a lot of architects and engineers use during the design phase of a project to start to lay out a building and really start to get interactive with the digital content. And that's where the SketchUp viewer for HoloLens application came into play. And this was really an opportunity to take this mixed reality application and really get immersed inside the model and experience it at a one-to-one scale. And then from that, we sprang forward into developing an application that actually goes into construction, creating the Trimble Connect for HoloLens application. And then with our partnership with Microsoft, we decided to develop an application that allowed you to take that HoloLens, attach it to a hard hat, and bring this information out to the job site. And so using the HoloLens application with Trimble Connect, you can now do quality control checks out in the field, or do craft worker training where you start to look at the sequence of construction, pre-plan your work with that digital prototype that's out in the field so that everyone can understand what they're doing before they actually start to do the work. And so I've got a little video here that kind of shows you what that application looks like. So this is what you'll see when you put on the HoloLens device and you're out in the job site. So using Trimble Connect for HoloLens, you take your models, you come out to the job site, and you let the HoloLens map its environment. So that's what you're seeing here right now, where it's going out, mapping the surfaces in its environment, and getting an understanding of where it is located. And then once it has its areas all mapped out and creates that kind of polymesh model so it understands where surfaces are, you then go through the environment and you identify planes that are in both the physical environment and are also in the model environment. And so you identify those planes, you tap on one, tap on a perpendicular plane, and this allows Trimble Connect to then align the model to the physical environment. And so once it has this information, it snaps the model to the correct location, and then it shows the model for you, and then you can make fine-tune adjustments if you want to change where the orientation is or the alignment is based off of what Trimble Connect did. But then once that model gets aligned out to the job site, now you can start to interact with that information out in the field. And so this is what construction teams are starting to do with this from a quality control standpoint and a training standpoint. But then you have this information, you can walk around it, you can start to interact with it, and you can actually see how that new information is going to interact in the actual environment before it gets installed. But then as you start to work with this application, we have features built in that allow you to do a collaboration type of meeting. So say an issue comes out in the field and you need to call someone back in the office, they can jump into that same model that you're working with out in the field while they're back in the office. You can also go in, take measurements off the model. So you can do real-world measurements, going real-world to real-world, model to real-world, or model to model type of measurements. And all the information around this is meant to promote this kind of interaction with the digital environment while you're out in the physical space. And then the next area that we're starting to move in with the mixed reality applications is around a VR application called Trimble Connect for VR. And this is actually a beta project that we just released just a few weeks ago, actually, at our user conference. And this is intended to take kind of next step where you start to take that digital content, we go into a virtual environment, and start to take the digital prototype and then bring in real-world information from 3D scans. And when you bring that information into both this digital content with the scans and the real-world environment, you start to get immersed inside of that application. So again, it's allowing you to interpret things and start to interact with things, but instead of being in the actual physical environment, now you go into this virtual environment. And so we're bringing both scan data and the models together into that same location. And then the next phase that we're starting to look at is around operations, where we're going to take the idea of taking all this digital content, moving into operations, where, put on a device like a HoloLens device and begin to walk through the environment. And as you walk through that environment, little nodes of information will pop up for you. And as you click on those nodes, it links back to a database of information about the building. And you can learn everything about that piece of equipment, when it was serviced, when is its next maintenance due, any of the owner's manuals. All that information now starts to be populated as you walk through the space. And so this is an area where we're starting to just do some research, proof of concept type of things. But the idea behind it is to add 3D context to that facility records that you have in the job site. So what is the next big thing that we have coming from this type of kind of mixed reality applications? Trimble Site Vision. So everything that you've seen right now with the HoloLens has all been really geared toward interior applications. But as we know, construction also happens out in the physical environment as well. And so Site Vision is taking the idea of an augmented reality application, because when you have HoloLens, it doesn't work well out in that outdoor environment. And so we want to go with an augmented reality type of application in this particular context. And so this is a project that we started with Google using the Tango project. And so we were taking the Google Tango tablet and then using one of our GNSS receivers, we built a little holder kit for both of those types of applications. And so this allows you then to take the model, go out to the job site, and then using positioning technology from the satellites, you now have that model located exactly where it needs to be on the job site. So in this particular case, you have that digital window. So as you walk anywhere out on the job site, you lift up the digital window and you can see that model overlaid on the physical context. And so this has been used primarily around civil type of applications with road construction, any of the highway construction. But it's also going to be adopted toward a buildings environment as well, where you have underground utilities being built and coming into the overall job site. And then some of the new areas that we're going to start to work on is this idea around remote expert. We have the ability, this is something that MEP trades have actually asked a lot about, where they do a lot of service work on buildings. But they have a lot of young technicians that have just come out of school, but the folks that have the experience are back in the office. And so this is a way of kind of duplicating and cloning those individuals back in the office to have them out in the field with the young guys and teach them what's going on. And so this remote expert idea allows both the person in the office and the person in the field to see the exact same thing. And so you'll have this little window that pops up, and then that person in the office can see exactly what you're seeing. And as they're talking to you and explaining things to you, they can actually draw in your field of view. and you'll start to see instructions on how to interact and how to do things out in the job site. So as you can see with the image here, and the indication here is he's drawing a little arrow saying where to install the trap on the drain there. And then you also have, we're doing information around real-time information, IoT. This is actually the Connected Mine application that we developed with our mining division. And in this particular case, using the HoloLens device, you can be in the job site and using the tracking information on all the construction vehicles out in the mine pit, you can be able to use that HoloLens application to be able to view those locations in real time as you're watching the model. So it's constantly updating itself in real time as you watch it on the model. And then the last area that we're starting to focus around is around object recognition, AI, machine learning. You know, when you have the HoloLens device and you're in that interior environment, it knows where it's located. It's constantly mapping its environment. So there's no reason why you can't tell it to start identifying objects and start teaching itself about the environment that it's in. And so the idea behind this is allowing it to start to kind of identify, you know, where are things changing on the job site? Are there unsafe conditions that are popping up? But being able to take the information that's using to position itself and start to learn from it. And so this is kind of the next area where we're starting to take that information and starting to develop more and more context around. But for us, the evolution continues. The information that you've seen today is stuff that didn't exist 2 years ago. So you can only imagine where things will be 2 years from now. But for us, this evolution continues. You know, this is kind of where we're at, but it's only the beginning of where we want to take things around the mixed reality applications. And so with that, thank you very much for your time today. If you have any questions around any of these applications, we're at our Trimble booth just outside the door there. Happy to answer any of the questions you might have. We've got some of the technology here that we can try out for yourself. But if you have any questions, feel free to stop by and we'd be happy to answer any of your questions. With that, thank you so much and appreciate your time.